So, according to the principle of reversibility of light, now we are going to know about refraction of light through many mediums, means more mediums. Here we are taking also, we can say that also refraction of light through a rectangular glass slab. This is the ABCD is the glass slab, ABCD is the glass slab, and when the light ray is ABCD is a glass slab. Next we are going to know that from the K to light ray is incident on the face of AB. K light ray is incident on the face AB, and with the angle of incidence is I1. Means angle of incidence here there whenever the at on AB light incident at point L. Light incident at point L, and the refractive index of the air, and it is refracted into the glass slab with a refraction angle is R1. Means here is the normal and it is the angle of incidence I1, and it is moved towards the normal, and this the angle of refraction is R1. So here it is that the refractive index of glass with respect to air, when the light is traveling from the K to incident on the point L. At L we are knowing that the refractive index of the glass tube with respect to air, that is equal to mu g by mu a. We can write that is equal to the angle of sine. Incidence angle is I1, so that's why sine I1 by sine I2. This is the equation number, sine refracted angle is R1. Sine I1 is the incident angle, and here is the refracted angle R1 is equal to sine R1. So here we are going to know that this is equation number 1, and it is moved through the glass slab, and another surface is refracted at point M. At point M also the ray is refracted, means at M again light refracted. So here it is that whenever the light is refracted at M, then the refractive index of air with respect to glass is equal to, means mu a by mu g, means refractive index of a means refractive index of air by refractive index of the glass. Here is that we can write that refractive index of the air with respect to glass, because of the light is moving from the glass to the air. So here it is that sine, here is the I2 be the incident angle, so sine I2 by, and whenever it is refracted through the face of CD, then at the glass slab, then here it is the angle of refraction is, it is moving away from the normal, which is parallel to the actual path of the light. This is the actual path of the light is parallel to the light, because of both mediums are same. Here is the refractive index of mu a, and it is also air. Both are air, between the air is a glass is placed, so light ray is passing parallel equally with the incident light. So here it is that the refracted angle is R2, so sine R2. Consider it's a equation number 2. When an obstacle placed at N which is perpendicular, means maintaining 90 degrees, which is perpendicular 90 degrees, then the light ray is reversed. The light ray is reversed, means a light ray is reversed at N. Then whenever it is reversed, the light ray is moving from the rarer medium, means air, to the again glass. According to the principle of reversibility of path of light, the light ray will travel, move back along the same path. So here it is that whenever it is moving air to the glass, then the refractive index of glass with respect to air, because of it is moving from air to glass. So we are measuring the refractive index of mu g by mu a is equal to, whenever it is moving from the point M, at point M, reverse at N at point M. At point M we can get that that is the incident angle will be R2. So sin R2, whenever the light ray is reversed, the incident angle will be R2 by, and the refracted angle is as usual, that is I2, sin I2. So here it is considered say equation number 3. By measuring that, the multiplying the equation 2 and 3, multiplying equation 2 and 3, equation 2 and 3, we can get that equations are refractive index of the air with respect to glass to the refractive index of the glass with respect to air is equal to sin I2 by sin R2, that is equation number 2, and into the equation number 3 is sin R2 by sin I2. Here is that by cancelling the same terms, then we can get that is equal to 1. From that equation we can get A G into, here it is the refractive index of the air with respect to glass, and it is the refractive index of the glass with respect to air is equal to 1. From that equation we can get the refractive index of the air with respect to glass, which is equal to the reciprocal of refractive index of the glass with respect to air. From this equation we can get this. Here then what is the angles, or instead if the angles must be equal whenever the retraced path is back. When the light ray is retraced its path, then the angles of it must be R2 is equal to R1 and I2 is equal to R1 must be like that. So here it is there, the angles also same, because of from the equation 1 and 3, from equations 1 and 3, from 1 and equations 3, that is both are is equal to the refractive index of the glass with respect to air. Here is also refractive index of the glass with respect to air. So here it is that both equations can be same. Here, so mu refractive index of the glass with respect to air is equal to, both are the from equation number 3. Then we can write the equations also. Here sin I1 by sin R1, that is equal to, here it is that sin R2 by sin I2. From that equation, that is I1 is equal to R2, we can write sin R1 is equal to I2. So from the angles we can write that I1 is equal to R2, same as R1 is equal to I2. From the equations, whenever according to the principle of reversibility of path of light, then whenever the more number of slabs are placed like this, more number of mediums are there, then whenever the light is passing from the air to the glass tube, the incident angle will be I1 and refracted angle will be R1. So here it is that the formula refractive index of the glass with respect to air is sin I1 by sin R1, that is equation number 1. And again at point M, the light is passing through the glass and again refracted another end. So that's why here the refractive index of the air with respect to glass, so sin I2 by sin R2 is, here is the incident angle is sin I2 and refracted angle will be R2. So a light ray is reversed at the point of N, which is perpendicular obstacle is placed, then the light is reversed backward. So it is maintaining the same path, it is moving along the same path according to the principle of reversibility of path of light. So from that, it will R2 will be the incident angle. So that's why we are writing that sin R2. And again whenever it reaches to the point M, the light ray is refracted. So that's why that will be refracted angle will be I2. So here it is that sin I2. From that equations 2 and 3, we can get that by the cancelling the same terms. Then we can get that the refractive index of the air with respect to glass, which is equal to reciprocal of the refractive index of the glass with respect to air. If in case of whenever it retraced backwards in the moving to the same path, then angles must be equal. From the equation 2 and 3, from the equation 2 and 3, here the sin I2 by sin R, sin equation 1 and 3. From the equation 1 and 3, equation 1 is sin I1 by sin R1, sin I1 by sin R1, and then equation number 3 is sin R2 by sin I2, sin R2 by I2. So that's why both are the equal. So I1 is equal to R2, and whenever R1 is equal to I2. So here it is that whenever the light is passing from this I1 angle is equal to this R2, whenever it retraces back, then the same angles can be measured, can be observed in the 2 points. And here is also the 2 points is there. R2 I2 is equal to R1, I2 is equal to R1. So the same angles can be measured, can be observed while whenever it is moving in the refracted path, and it in the reverse direction also, same direction also, the same angles. And this is the equation about whenever the light ray is passing through more mediums, means many mediums, then we can get the equations.